These are guided practice problems from lesson 4-5, which introduces the angle side angle congruence postulate and the angle angle side congruence theorem. Okay, as with any proof, almost any proof, I want to draw a picture first. I've done that, and I also want to record the given information. So we're told that segment GH is parallel to segment KJ. That is the top segment here is parallel to the bottom. And the left side, the left is congruent, is parallel to the right side. So let's draw that. Okay, now they have not given us any explicit information as far as angles that are congruent or sides that are congruent, but we can figure this out ourselves. So we like two-column proofs, statements in the left side, reasons in the right. Okay, the first statement is always the information that's given. Rather than rewrite this information, I'm simply going to draw a line and state my reasons for knowing this. I know this is true because that information is given to me. To prove these triangles are congruent, I'm going to need to show sides are congruent, angles are congruent. And so I'm going to look at the picture here. Obviously, for the bottom triangle, this side, GJ, is the same length as the top triangle side, GJ. That is to say, GJ is congruent to GJ. The reason we know that anything is congruent to itself is called the reflexive property. Okay, and now we're going to have to find out more information. You might be tempted to say that the left side and the right side are congruent, or the top and the bottom are congruent, because they look congruent, or because they're parallel, or something of that nature. But none of those things are necessarily true. And so we're going to have to look for angles instead. This information about parallel lines is going to be very helpful in this regard. So, for example, I know that the top of this parallelogram, or these two triangles, this quadrilateral, is parallel to the bottom. I have several transversals here. The one that's most important is this one that cuts through the middle, because it creates angle HGJ and angle KJG, and they are congruent to each other. They're congruent to each other because they're both between these lines, which is to say they're interior angles. One of them is on the right side of the transversal and the other is on the left, so they're alternate interior angles. So that is why I know that angle HGJ is congruent to angle KJG because of the alternate interior angles theorem. Now, moreover, and I'm going to have to highlight in a different color. I hope this isn't too confusing. But I also know that the left side and the right side are parallel, and we use the same transversal. And in this case, I can see that KGJ, this angle, is congruent to GJH. I'm going to write that. I'm going to continue that as my third statement because I don't need a new reason. KGJ is congruent to HJG. And again, the reason is the same, because they too are alternate interior angles. Now, if I look at these triangles, and I realize that the highlighting makes it quite difficult to see. Well, that's not going to help. If I look at these two triangles, I'm just going to draw one of them. I'll draw the top right triangle. I know information about this angle, and I know information about the side that's between those two angles. That is the included side. And so for my next statement, I'm going to state that these two triangles are congruent to each other, and the reason is, well, I've got two angles, and the side that I know is between the two angles. So the S that I write down is going to be between the A's. Angle, side, angle, congruence postulate. And the statement, well, we have to prove that triangle GJK is congruent to triangle. Now, rather than simply copy this second part of the congruent statement from what I'm told I have to prove, I'm going to look at the picture and make sure if it's true. G corresponds to, well, G has 2 marks. That's going to correspond to the J in the upper right triangle. J in the bottom triangle has 1 mark, which corresponds to G. So K has to correspond to H. And we're done with our proof. Okay, for number 5, we have to prove these two triangles are congruent. We have 4 ways to do it. First thing I'm going to do is write down the information I've been given. Segment XW is parallel to segment YZ. Okay. We're also told, they straight out tell us, angle X is congruent to angle Z. Well, that's good information. I've only got to find 2 more pieces of information before I can prove these are congruent. Statements, or the given, the first statement is this given. The reason we know it's true is because it's given to us. The second statement, well, hopefully you can just look at the picture and tell that WY in the top, or the left triangle, is congruent to WY in the right triangle. So our statement is going to be that WY is congruent to WY. And the reason we know that it's true is because of the reflexive property. So we've already got 2 pieces of information. We just need 1 more. Okay, so again, I'm going to highlight the parallel sides. I'm going to draw the transversal that separates the triangles. And hopefully you can see that this angle and this angle are alternate interior angles. We know they have to be equal. So our third statement is that angle XWY is congruent to angle WYZ. We know that's true because they are alternate interior angles, and the alternate interior angles theorem says they're congruent if lines are parallel. That's all the information I need. I'm ready to write my triangle congruent statement. I'm going to read the first 3 from what I'm told I have to prove. WXY is congruent to triangle. Let's see. WXY is the top triangle. The one with 2 marks, W, corresponds with the Y. X has 1 mark, which corresponds with Z, and then the other one has to be W. How do I know that? Well, again, if you redraw the triangles, I'm just drawing the top one now. I know this angle, and then a non-included side. So I've got 2 angles and the side that is not between them. So it's going to be angle, side, congruence theorem. Finally, number 6, segment QS bisects angle RST. Okay, so if this segment bisects, we know that means it cuts it in half. That means angle RST is cut in half. Well, that means this top part and this bottom part are equal to each other. They're each half of the large angle. So I can write that down. That information I'll need to statements, reasons. Our first statement is written right up here. The reason we know it's true is because that information is given to us. The second statement, okay, I got a little bit ahead of myself, but this is our second statement, that these 2 angles are equal to each other. Angle RSQ is congruent to angle TSQ, and the reason we know is because it's the definition of angle bisector. I'm just going to write the definition of bisect. It's what it means to cut something in half. The 2 parts are going to be equal to each other, or congruent. Okay, they also tell us R is congruent to T, so I'm going to write that with 2 marks. Now, I don't need to state this because it's a part of the given, so I've really already written it down, if you will. I've already got 2 pieces of information. I just need a third to conclude that I have congruent triangles. Well, QS and QS are congruent to each other. QS is congruent to the segment QS. The reason I know that is, again, the reflexive property. And now I've got all the information I need. If I just draw one of the triangles separately, I've got information about this angle and this side. Hopefully, while I'm writing this, you can see what postular theory I'm going to use. QRS is congruent to triangle. Well, Q corresponds with Q. R and T are equal, and then S and S. And the reason, well, I've got 2 angles and this side, but the side's not between them, so the S is not going to be between the A's. All right, and that is all 3 proofs.